Okay, here we are, 6.8. Guess what? We've done this before. You can do this. It's translation of roots and square roots, cubic roots. Okay, so we need to be able to do parent functions before we can translate move it left, move it right. So you need to know what it looks like generally. Let me turn this off. All right. So please, everyone, graph these two functions. Consider a bunch of points. This is the cubic root. Consider a bunch of points. Don't just do 2 points and then start graphing. Don't do that, dude. At this point, don't do that. And then please consider 0, some negative numbers, some positive numbers. I suggest that you pick good numbers, such as 1, 4, 9, or -1, -4, -9. See what happens here? And over here, obviously pick good numbers, graph it using a couple points. Use some zeros, use some -1s, use some negative 9s, positive 9s. The next one, it'll be, use 8s, 27s, 64s. Okay? All right, pause the video and graph it. Okay, now that you have graphed it, what does it look like? Obviously, with that, x cannot be negative numbers. You know that. We talked about it, domain and stuff. Okay, so the graph looks like this. You can see that y increases, the range increases slower than the domain. Y increases slower than the x. If you put in, for example, 100, y will only be 10. But it will eventually get there. For example, if you put in 1 billion, y will get bigger too. Okay, let's take a look at this one. This time is different. 0, 0, 1, 1, -1, -1. Cubic root, you can have negatives. Okay, 8, 2, -8, -2. 27, 3, -27, and -3. If we graph this, it will look like this. Okay. Now, with the parent function in mind, now you know the parent function because you graphed it. If you don't believe me, obviously you can put in Desmos. Let's try to shift it around. Okay. Everything stays. Everything that we learned before you should remember. Okay. Let's take a look at this one. This one's easier to graph. So let's do that. I'm going to do a quick review. Hopefully you know how to shift this function around a little bit. Okay, this one, what does it do? Up 6. Okay, what about this one? How do you shift this function from the parent function? Left 5. What about this one? Okay, this one is a reflection across y-axis. And then this one is a reflection across the x-axis. So reflection across the x. Okay. What about this one? If you put in 50 square root of x. Okay. This one will be a stretch. This one will be a vertical stretch by a factor of 50. Okay, that's enough review. So we're going to do this one. graph this from the parent function, please. Roughly, you don't have to plug it into an XY chart. An XY chart and find the values and graph it that way. No, just graph it roughly using the translation skills that you've learned it from the past. Okay, pause the video. Do that now. Okay, now that you've done it, let's look at some basic things. We know the parent function looks like this, square root of x. Square root of x is the parent function. Okay, now it's been shifted. Please look at the order. The order matters a lot. I bet there's still a bunch of you don't know the order. The x is first affected by this, so you should do that first. And then it's affected by this, so do that second. And then you add the 1, and then, so that would be the last thing that you do. So I'm going to use a blue marker to show you the. So first it's been shifted 3 to the left, to the right, sorry, like that. Okay. Now it's been compressed by a factor of 1/2. So it now looks like this, compressed. Okay. Now the regular y, imagine this negative is not here. It will be a positive y. Okay. But if you add a negative, y becomes negative. So that means that it flops like that. Then finally, it moves up 1 unit, plus 1. So the final answer will be like this. That's all you have to do. Okay? All right, next. Let's do y equals to, let's just say 6 cubic root of x plus 1. And minus 4. Why not? Okay, pause the video, graph it now roughly from the parent function. Go. Okay, now that you have done so, how would you graph this one? First, you look at this x. Well, first you need to know the parent function. The parent function looks like this. Okay, it's been shifted 1 to the left. So 1 to the left. So it looks kind of like this, right? And then it's been stretched. I'm going to use the blue one now so you know what's happening. Stretched vertically by a factor of 6. And it's made bigger. It's made wider. Okay, and then now 4 down. So this will be 1, 2, 3, 4, for example. Obviously, this is not perfectly accurate, but it does. Okay, so I ran out of space, but you know, it goes this way. Okay, so I guess I'll put it over here. So it's going to be something that might look like, it'll probably look something like this. Okay. All right. Last one. Last one. Y equals to square root of 9x plus 18. Okay. However, this problem looks a little different because normally whenever we shift left and right, up, down, compression, flipping, reflection, whatever, it's always square root of 1. I mean square root of 1x. So this time is 9x. So like what I mean is like, okay, so we do this, we can tell that it's been shifted 3 to the right. But if it's this number, then you don't know properly. So you have to make this function look like something that you know what to do. Okay, I suggest that you factor out something. Okay, please try it. Pause the video. Go. Try to graph this one. Roughly. Okay, unpause it when you have done. So first, let's factor out 9. Right? Square root of 9, 3. Square root of x plus 2. Oh, guess what? We actually know what to do. So in this one, now we can graph it. The parent function is this one, it's been shifted 2 to the left, so like this. And then finally, triple. It's been stretched by a factor of 3. That will be your answer. Okay? All right.